Okay, so let's just jump right into it. Today we're going to be talking about object-oriented programming, and just to get kind of a gauge of the room, how many people here have like taken the object-oriented class and like feel like you really understand object-oriented programming? Okay, so a handful of people. I don't know, Zoom, we have a number of people on Zoom as well, but I'm going to spend at least about the first half of the workshop just talking about how you can apply like object-oriented concepts to an actual program. So I actually have this tic-tac-toe game, very simplistic, kind of built up here. And we're going to take that, and it's just written in a very procedural, like kind of like you would write it in C sort of style. So we're going to take that and transform it into an object-oriented program and discuss like why that's actually something you'd want to do. Because a lot of times I feel like people understand like, oh, object-oriented, like this is what you need to do, but they don't understand why it's good or when you shouldn't use it. So we're going to talk about that. And then if there's time, I also will try to get into the solid principles from Robert Martin, which are basically a set of object-oriented design guidelines. They're kind of like ways to tell, like, are you doing things correctly? Like, what are some signs that like maybe your code isn't as good as it could be? Okay, so let's hop into this. Let's just actually run this program first so you can see what it does and how it works. So right now we just have this one file, game manager.java. And if we run this, it basically is a very simplistic tic-tac-toe game. So these are just drawn with all individual characters. It's actually something really cool. Box drawing characters, you can get them. And if you print them in certain patterns, it'll like actually connect across cells. So like you can make it actually look like there's lines. But you can also just do hyphens or whatever if you want to do something similar. And so at the start of the game, right, everyone knows tic-tac-toe, everything's empty. And I can go ahead and enter a move I want to do. So say I want to place my X in number 2, okay? And then you see the computer has played a move. The AI is very tough to beat because it uses the random method to determine what move it's going to make, which we'll see in the code. You can see the computer made its move. Okay, maybe I'm gonna go, I'll take the middle. The computer made another random move. I'll go to 8. Okay, I won, and you can see the final state there. So it's currently working. Like I wanna express that like the program, it's fine that it currently works. But there's more to object-oriented programming and programming in general than just it works. Things like readability count, things like design count. And so one problem we have with this program is it's just one giant 150-line monolith of code. Okay, so the whole thing is just one big file, one big class. There are some different functions. I didn't just write it all in main. But if we kind of scroll through here, let's go down to the actual main function here. So we set up this game manager object, and then we just start the game. And already you can kind of see some signs that maybe things aren't so good because you have these false and true parameters. And like, what does this mean? Nobody really knows, right? It's definitely confusing, especially if you're just looking at a brand new code base. And that's important because statistically, you're going to be hiring new people in organizations that you're in. If you're part of a company or part of a nonprofit or whoever you end up working for, or even just working in a group, you'll need to onboard new people. And so if your code is not easy for them to understand, that's not a good thing either. It should be, you should try to write code that's as simple for people who are brand new to the project to understand. Okay, so this is already kind of a sign maybe things aren't so good, but we have this start game function. So let's go take a look there and see what's going on there. So here it is right here. We have this Boolean is P1 equals true. So what this is basically doing is tracking whose turn it is. So is it player 1's turn? If it's not player 1's turn, it must be player 2's turn. And then we have this function is game over that we can call to determine if the game is over or not. And there's a couple different things we can get. This game state, if we go to this is just an enumeration. If you haven't seen this before, it's basically just a way to have like, if you have like, you want to say, okay, the game can be one of these 3 things. It can be a state where player 1 has won, it can be a state where player 2 has won, or it can be in progress. So you can have infinite, but a lot of times you use enumerations for things like, different states, like is this request failing? Is it still going on? Or is it complete? Something like that. Or for colors, that's the uses you can use for it. But here I'm just using it to represent who's won the game or whether we're still going. Okay, so we go back down here. So while the game basically is still in progress, if it's player 1's turn, we're going to check is player 1 an AI. So actually the way I've set this up is you can make it so to have 2 AIs play against each other, or you can have it so 2 players can play against each other and just kind of like tag team, like drop in and out. So that's what this does. And so we check if it's player 1's turn, then we go to see is player 1 an AI. If it is, then we do an AI move. If not, we do a player move. And then same thing over here. So if it wasn't player 1's turn, it was player 2's turn. And so then we go do an AI move if they're AI. If not, we don't do that. Okay, and so this works. It's fine. And then the very last thing we do at the end of the loop is switch the turn. So we just flip that Boolean to the opposite. So we know whose turn it is. And when it finishes, we'll get this game is over and we'll get to see, okay, who won the game. That's what this whole line does. And then we'll print out the board. So now we can start to figure out maybe what these parameters here do. If we actually go up to this constructor here and figure out like what are these parameters for? So the first one is telling us whether player 1 is an AI and the second one is whether player 2 is an AI. But in general, Boolean parameters are maybe something you want to avoid. Just because of this, they're kind of confusing at the call site, like what does this mean? Okay, so that's the basic structure of things. All these other functions are just helper functions that help to achieve that main loop. So I'm not going to spend too much time on them. But let's start looking at kind of the first one of the object-oriented design principles that you want to look at. So the first thing you want to consider, and this is by far like the one that you'll use the most, it's something called the single responsibility principle. And basically what that means is you want every class, function, or module, you want to have a single responsibility. And so what is a single responsibility? Sometimes people will say, oh, single responsibility principle means every class should do one thing. But I don't like that definition because what is one thing? It's a difficult question, right? And you can even if you have code that's not written well that should be refactored according to this principle, you could say like, oh, like this code right here does not adhere to the single responsibility principle. But I could say, oh, it's the game manager. What thing does it do? It manages the game. But that's not really where you want to be. So I think a better way to think about the single responsibility principle is that every function or class or module should have one reason to change. And that helps you pick apart when your classes don't follow that. So if we look at this class game manager, by the way, classes that end with manager are kind of an anti-pattern and probably indicates your class does too many things. If what your class does is so broad that you're saying manager is like a good way to describe it, see if you can find a more descriptive word for it, and then you might realize that it should be 2 or 3 classes. So in this case, game manager basically handles everything about the game. It handles the players, right? It handles the board. We also have a scanner so that we can scan the input. It's taking care of that. And we have a random variable that we can use to generate random numbers. So it has, you could say 1, 2, 3, it has potentially like 4 responsibilities. And so that's not good because it makes it harder for people to understand the code, right? Even though we sort of were able to walk through the basic skeleton there, if you wanted to read this whole class, you have to read all 150 lines to understand how everything interacts. So in object-oriented design, what you want to do is decompose these large classes or large functions into smaller ones that are easier to understand. And that way, it also makes your code less buggy. Because when you have a problem, if I have a problem with this program, I have to go look at all 150 lines. It could be really anywhere in here. If you break it down into multiple files that are smaller, you can tell like, oh, like the board isn't displaying right. Let me go check out the board file. And maybe that's only 50 lines. And so now you've dramatically cut down the search space of what you need to look for bugs. So it just helps you in a lot of ways to not write all of your code in one file. And I think like, unfortunately in classes, you don't often get to write, usually like you end up having to submit one file just for ease of use or whatever. But almost always you should write like one class per file. So let's start trying to like decompose this down and make it a little bit more adherent to that single responsibility principle. The first thing I want to do is extract this board. So if we can kind of bring that into its own isolated thing, the board basically handles like, the way I'm representing is just a character array. And so you can see at the start here, it just has numbers in it, and that indicates that there's nothing there. And it also kind of provides that UI, like you can type the number you want to put it where you're going to put it. And as the game goes on, it overwrites these with an X or an O. That's basically how it works. So if we can just extract that logic out of here, we'll be able to shorten this file a little bit. So let's open up a new file, board.java. Okay, and let's start the easiest way to refactor something is just start ripping things out and putting them into the new file. So over here, we know it's board.java, so we're going to need a public class board. And let's just start taking things out. So like this character array, that can go over here into the board here. You can see our constructor where it's already giving us the warning because this board is no longer here. So let's go ahead and take that and put it over here. And let's set up our constructor here. So public board. All right, so we've basically moved that over to there. That's great. And then if you're able to set up your editor to have like inline like warnings, you can see like it knows this line has some problems. It makes it very easy to see like what broke. And so you can just port that stuff over. Okay, so we have this print board function. Let me move this up here so you can see a little better. We have this print board function, and basically that's what's doing this printout every time. So it's the algorithm that takes care of that. That's basically, if you think about it, that it's directly tied to the data that's in board. So it makes sense for it to be in that class. So we can just cut and paste that over to here as well. All right, and let's see what else we have. Move it back over to the right. Let's see, is there anything else broken? Okay, so so now we're starting to get into some more like implementation detail stuff. This check rows function is basically checks each row to see if anyone has won the row. And there are much smarter ways to do it than this, but basically the way that this program works is every time someone makes a move, it checks row 1, checks row 2, checks row 3, checks column 1, column 2, column 3, it checks both diagonals. And then if any of those are all the same, then somebody won. And so if you had a much bigger like board, this might be a bad idea, but it's fine for this. So this check rows function basically just handles the row checking part of that. So we can take that. There's also this check columns function, which is the same thing for columns. So we take that, and this diagonals function, same thing for that. So we'll take all of those and move those into the board. And the reason we're moving them into the board is because they have to do with the board. So object-oriented programming is all about combining data with operations on that data. Okay, so like other things that aren't really as directly tied to the board, we're not going to move there. We're not just moving everything. It's only things that are sort of tied to that. So we're moving that stuff over. That's great. Let's see, what else do we have? And now we can see this is game over function has also broken because it relied on all of those functions. And so let's think about it. Does it make sense for is game over to be part of the board? I would say yes, because in this case, the responsibility I'm giving to the board is maintaining the state and maintaining the rules of the game. So this is, it's going to be able to set different values into the different cells. It's going to tell you when someone has won. That is what the board is all about. It doesn't worry about where the moves come from. It doesn't worry about generating random moves for the AI. None of that is involved, or reading input. None of that has to do with the board. The board just takes care of like printing itself, keeping track of like actually what the state is and whether anyone has won. So let's move the is game over as well. Okay, so we moved that over. Now we can start to see some other things aren't working anymore. So like AI move here also relies on board. So you might be tempted to just go ahead and grab it and move it over to the board as well, because like that's what we've been doing so far. But in terms of responsibilities, you want to think, remember, everything should have one reason to change. So the board class, the only reason it's going to change is if we decide how we want to change how we represent our board. We want to change the rules of the game, right? That is the stuff that the board is responsible for. But like I said, it doesn't really make sense for the board to be responsible for what the AI is going to do or what the human player is going to do. So it doesn't really make sense to move this AI move function into the board class. Okay, but so how do we get access to the board so we can still do the work that we need to do? One way is you can pass it in as a parameter right here. So we could just say, okay, we're going to pass that board in as a parameter. That way you have access to it. The problem is we also don't really have access to it in this whole game manager class anyway. So we can't really do that. So what we'll do instead is just add it to the class as a whole. So we can just add a board object to here. And this is a common pattern. It's okay that you like basically extracted this to a new file and then you're just using it within the original file. It still helps the readability. It still helps the code to be more concise. That way, like at the end of the day, like now we've got like 70 some lines over here and we've gotten this down to 81. Those are two files that are both more digestible independently. So you can try to read either one and it's a little bit more than just trying to read like 100 some lines of code at a time. So we'll move this over. We'll have to import it. So, oh, didn't like that. Probably just because I haven't written this in a while. Okay, now it seems to be happy. And now all these warnings are gone over here. We do still have some problems because a lot of those functions we're using are no longer before, like this is just like a this dot, right? By default in Java, basically, if you just call a function, it's going to try to do this dot, that function. But we've moved all those to the board. So no problem, we can just do board dot now. And why is it angry about that? Board cannot be resolved to a type. Oh, it still seems to be mad. Let's see, let's try opening it back up. Sometimes that will fix it. Okay, it seems to be happy about it now. Okay, so if we go down to these, we have this board up here. And let's see. Oh, okay, so now it's angry that the board isn't an array anymore, which is true because we made it into a class. So what we can do is basically if we want to go into the board, one thing you can do is you could make the board like a public variable. If you make it public, then other people can just directly access it. But that's also bad object-oriented design, because usually in a class, you want to make all of the members private. The reason you do that is so that you can change the implementation later. So right now, the board is represented as a two-dimensional character array. But maybe later we want to change it to a linked list, or we want to change it to a one-dimensional array, or we want to like back it with a file or something. Like, who knows what we want to do. We want to be able to make those changes to the board without anyone else in the program having to know about it. Right? You want like a situation to run into with having like one giant file like we had before is like, say you want to make a change like this and you want to back the board with a file. Okay, you go to change that, but now something else will break. And then you go fix that, and something else breaks. And it's like whack-a-mole with different bugs that will come up just because everything's so tightly coupled together. So if you make all of your member variables private and only expose functions, then as long as you make the functions continue to work, it doesn't matter how it's implemented in the background. Like if we swap this out for like a linked list or something, as long as we still provide the same functions as before, we'll be able to continue to use the class the same everywhere else. And so that's like sort of the value of doing object-oriented programming. You can change your implementation, but people can still use your class in the same way. But we still have the problem that people aren't able to actually set values into this board. So one thing we can do is just provide like a set function. So we'll just provide a public set function, and we'll just take in the indices that we have for now. And then also the thing that we're usually setting is a character. So we'll just pass in a character C to set. And then within the class, remember, you have access to these private variables. So now we can use that for our board here. So set this to I. And for this, it doesn't really add a whole lot of value. But later, if we want to change how that board is backed, so we make it into a linked list, then all we have to do is change this function. And everyone who was calling the set function doesn't even have to know this happened. Okay, and oh, it's mad we have no return type. So we'll set to void because we don't need to return anything for set. We're just going to do a set. And then for all of these, we're going to change this to a set. So let's do that. The other thing we're going to need is some kind of get, because we also like want to read from that array or read from the board. That way, like especially for the AI, if it wants to like make decisions about like, oh, like where am I going to play or something. This one is just kind of random, but it does check to like make sure it doesn't try to play an illegal move. So we can just make a get function, very similar to set. You'll see this is pretty common to make like get and set functions for your different variables in your class that are public, even though you have the variables as private. Okay, so it's basically the same thing. We're going to pass in the indices that we want to go to. And we're going to look up that value, and then we'll just return that to our caller. Oh, and it shouldn't be void. It should be a character because we'll return what's in that spot. And now we can rewrite all of these where we're looking things up into that. Oh, and this needs to be comma C instead of the equal sign. Okay, here's some more examples of where it should be board.get. So we can set up that. And then the other thing you'll notice up here on line 34 is that we have a print board. That print board function doesn't work anymore, right? So we were calling this .print board before. But now that method has moved into the board class. So remember, instead of this, it's just going to be attached to the board because we have board right here available to us.
I have a question.
Sure.
Suggestion. For print board, you don't even need to make another function to work, just override two strings.
That's a good suggestion. We're going to do that later at some point. Okay. Yes. That's an excellent. Yeah, no, that's a good spoiler. But yeah, that shows like a good understanding of design. And if you want, why don't we just go ahead and do that? We can take care of that now since you brought it up. This would be an example of something called the open close principle. The reason why it's better. So what basically the suggestion that we have from Sunit here is that we have this print board function, right? And so we go throughout, and this basically it prints the board. So if you want to see, like here, let's just close this for a minute. If you want to see how this works, like we're going to basically loop through all of the rows and then loop through the columns, and we'll print out the things. And basically all these ifs and stuff are just to make sure you don't print like extra lines on the outside, so you actually get like a grid. You can see this is all just checking if it's like at the end and stuff like that. And so that's all this does. It prints that out to string. And it's fine for the purpose of this program, but it's actually not very good object-oriented design. And the reason is because the open-close principle. The open-close principle states that software entities like modules, classes, functions should be open for extension, but closed for modification. Okay, so what does that mean? Because that's kind of like very academic-y kind of terms. Basically what it means is you should be able to extend the behavior of the program, add new features, change the way that things work without modifying existing code. And when you first hear that, it might sound kind of paradoxical. Like, how can we extend what the code does without modifying what already exists? Well, you can write new code to do things. But still, it might seem like, well, won't we ever have to go back and edit things that already exist? And the open close principle says, if you have a perfect design, you never have to go back and change anything you've already written. You can always extend the behavior of your code by writing new code. And the reason this is important is because the hardest thing to do in software development is to read and debug other people's code or your own code from 3 months ago. That has happened to me numerous times, okay? So that's the hardest thing to do. So we want to avoid reading old code as much as possible. Ideally, we would just write things, it would be perfect, and we never have to go mess with it again. So the reason that print board violates this principle is because it assumes that you want to print out the board. The difference between a print board and a toString is that with toString, it doesn't assume you want to print it to the console. What if you say we set that we later change the game so that it's networked and you can play it over the network with somebody else, right? Printing to the console no longer is going to be a very good UI option. We might want to instead send a string representing the board over the network, and then they can make a move and they can send us a string back of what the board looks like after that. But we can't do that with our current implementation because it just automatically prints it. Same thing if we wanted to say, well, what if we want to keep a record of the game as it progressed? So we want to like write it to a file or to a database, right? Same problem. Well, the code we have now is directly tied to system.out.print. It's going to print it to the console whether that's what we want or not, and there's no real way to capture it. And so with a toString, you're able to call the toString, and then you do whatever you want with that string. You can transform it, you can write it to all kinds of different mediums, and if we want to print it to the console, we can still do that. Question?
So basically what you're saying is that the compilation, the composition of the string should be a separate method than what you're actually using.
Correct. And usually what this means, so in terms of the open close principle, usually what it means is instead of directly printing things or directly making network requests, try to make as much of your code return values, okay? Void functions are a suspicious thing at best. Sometimes they can be legitimate, but what you're saying with a void function is I'm going to pass some data into this function, and then that function doesn't give me anything back. Okay, so what does the function do? The function does some kind of side effect. It like prints something out, it makes like a request, it modifies the global state somehow. All things that are kind of, they're very bug prone, they're failure prone. They're things that you try to minimize as much as you can. So when you have void functions, you should look at it and say, is this function just doing some kind of side effect? Is there a way that I can take the majority of the logic and extract it to something that will give me a value back? And so in this case, instead of this print board, we can override the toString method. And by the way, this @override is technically optional, but I recommend you always use it, because what it will do is if you don't set, like let's say by mistake we type int here. If we don't include the @override, it will completely let us do this. If we actually go and like return it, like if we go return 1, it's not going to be angry about that. Oh, I guess in this case it is, but at least in some versions of Java or in some cases, putting the @override signals to the compiler that this should override another method in another class, and if it doesn't, warn me about it. So it's technically optional, but always use it if you actually are overriding something. So we're going to override this toString function, and this, see, it's giving us a good warning here, cannot reduce the visibility of the inherited method from object. This is Java's way of saying it should be public, because the original toString is also public. So our version has to be public as well. Okay, and then it's also saying this method must return a result of type string. So we have to return a string. And so what we'll do is we'll just keep a string at the very top here that is like the return value. Just start with the empty string. And then anytime we print, we'll just append to that string instead. So, And you can use plus equals for this. This is kind of inefficient in terms of like concatenations. For this program, it doesn't matter. But if it does matter, you can use a string builder. Sure.
It's pretty much optimized out now.
Yeah, at least in older versions of Java, you had to use a string builder is basically like a mutable string. So normal strings in Java can't be modified, like they're immutable. And so if you just keep concatenating like one character at a time, it makes a brand new string for everyone. So like you'll have a string of length 1, then it'll make a brand new one of length 2, a brand new one of length 3, and that can waste a lot of space and time. But yeah, I know there's some optimizations, but there's some cases where the compiler still can't pick it up. Probably this one is straightforward enough that it can, but I mean, just the thing about performance is profile your application. If it's too slow, like you're like, oh, I have to like sit here and wait for this to happen, then optimize it. If not, it's not a problem. One thing we do have to do, so anytime we have these printlns, we're going to have to add an extra /n at the end because that's what println does. It basically just calls print with an extra new line at the end. And then here we'll just add that last new line. That should be good. And then we can just return that. And then if we want to restore the functionality we had before, so let's go back into Game Manager. And let's see, we had print board. So now it'll say this doesn't work anymore. If we want to restore the functionality we had before, we can just do system.out.print and pass the board in. And this is much better under the open close principle because system.out.print is actually like a very good example of the open close principle. Because think about this, I haven't modified system.out.print at all, right? It's the exact same code the Java designers shipped to me. Like I haven't gone and changed. There is a class file somewhere that has the source code for that method in it, but I haven't had to change it at all, right? It's been completely closed for modification, but I've been able to modify, I've been able to extend its behavior. It can print this data structure that the Java designers never knew about, anticipated, thought about, so that it's more flexible in that way. Their function is able to print anything as long as it implements this toString method. And so you can extend that behavior arbitrarily to do, like we could have the board print out, you know, as the game goes on, it can print like the toString can return different things. And so, and then that's how we can handle it changing over time. And like all of that, basically you're able to use a function that's already built in instead of rewriting your own. And now it's also available if we want to write it to a database, write it to the network, et cetera, log it to a file. We can now do that. We just call the toString function and then use that string, which we weren't able to do before without cracking open the class. So yes, this is a better design for the open close principle. Okay, let's go back to like fixing all of the other bugs in this program. Actually, might be getting pretty close. Most of it is just like the namespace thing. So we need to like put, and then here we can do the same thing, system.out.print. Board, and we should be good. Okay, so let's try this. So let's try running this and see how well that works. Oh, can I invoke this because it's null? I think this is because, yeah, I never actually set it up in the constructor. So what we will have to do, right, because by default, everything is null, and I never actually set it to be anything here. So that's problematic. So let's just pass in as a parameter for now. Okay, and then down here, we'll have to pass it in. So let's just make a board. Yeah, go ahead.
Instead of in the print or the toString method, instead of using a return charge at the end, just omit the return charge. Because what if sometimes we don't want the extra line?
That might be a good suggestion because then you could also just at every call site just do a println. I didn't even think of that, so we can do that. I don't want to spend too much time on this though because we do have limited time. There are things I want to get to, but yes, this is probably an improvement you can make. Basically, we just don't do this, and then whenever we call that, okay, we can just change this to println if we want the new line or not if we don't. In my testing, like it was nice to have a new line, so. But you know, in some cases, maybe you don't care about that, and so it's not a problem. Okay, so let's actually run it and make sure it still works. Okay, great. I beat the computer again. You know, he's got to work on his tactics. Okay, fair enough. So it still works. If you have normally when you're doing large scale refactoring like this, you want to test it like kind of iteratively as you go. Because if something breaks during one of the steps and you only realize at the very end, you're screwed. You'll never figure out what caused it. So make tests as you go, or write unit tests. And basically that's just automated testing. So now you don't have to manually do it. You just let the computer do the testing, easy peasy. Okay, so that's great. We've kind of adhered a little bit better to the single responsibility principle by extracting all the board logic into its own variable. We can try to do the same thing with our players as well. So right now the game has to worry about the board and still worrying about the scanners and also what the players are. It would be better if the players kind of were self-contained. Especially concerning is this whole construction here where we're like, especially this part where you're checking a type. It might seem like it's fine code because it does work. You check if the players in AI, then you do this if they are, this if they're not. But anytime you're writing code where you're basically doing a switch on a type, where you're saying like, okay, if it's this kind of thing, execute this code. If it's this kind of thing, execute this code. If it's this kind of thing, execute this code. That is a common sign that what you should do is use class polymorphism. So if you've taken object-oriented programming, you probably know what this is. If you haven't, we'll see here in a minute how you can take advantage of that. But basically, it will allow us to get rid of these if statements and just represent it as like player.makeAmove for both cases. So it's especially useful in these sorts of designs. It's not always the right approach. Sometimes you want to do something like this, but for most object-oriented designs, it's considered cleaner to do it that way. So let's make a player class. So, okay, so we have that. This one is going to be a little bit harder, mainly because we don't have a lot of the player stuff is kind of even more tightly coupled into the thing. So we might have to make some significant changes. One thing that we know we already have to handle is making AI moves versus making like normal human player moves. So how are we going to handle that? We'll see down the line. Let's just first extract everything to the player class, and then we'll try to figure out the rest of it later. So first, we know AI move and player move need to go. So we'll just throw those over here for now. Let's see what else. That's the main functionality we need, but a lot of the other stuff. There's some things we can do to improve this. So one thing is the way it works, at least on this side of design. If it's player one, we know it's supposed to be the X. If it's player two, it's supposed to be the O. So we're just passing that into this function every single time. To avoid having to do that, we know for a given player, you're always going to be using the same character. Like it's not like you can like switch teams during the middle. Like this is not how it works. So if we want to achieve that here, we can just pass it into the constructor and keep it as a class variable. So we'll just, every player is going to have their character. They're like, okay, you're X, you're O. When you're created, it's not going to change. So it's fine. And we can set that up here. So just pass that in. Great. And then now all of these in AI move and player move, we can get rid of this, these characters here. That's not a problem anymore. So that's nice. Over here, we can get rid of this as well. So now we're just going to have the players worry about whether they're AI or not. So one thing that I'll often do when you're writing a new class, don't just sit down and try to write the class completely from scratch. Instead, write the code that uses the class and see what would a nice API be? If you're using the class, how would it be nice to use it? And then write the class in a way that it can fulfill those expectations. So if I'm looking at this, I don't want to worry about whether the player's in AI or not. I just want to be able to do like player one dot make move, something like this, right? And then if it's player two, I want to be able to do the same thing for player two. Player two dot make move, right? And that's much nicer. We've gotten rid of that if statement. Now we worry about how do we actually make it work. So first, we need to actually have these players available. So let's put those up here. So player one, and we'll do the same thing for player two. And then that means we'll need to pass them in here. So now our constructor here. And then we have to change this as well. By the way, I will post all of this code to GitHub. So if you want to take a look at like the before and after and like do a diff or like think about how you can make it better or whatever, like I'll open source it, everything. Okay, it's still angry about the type. It might take a minute for the server to like figure it out. Well, now what we need to do is implement make move over here. So let's think about when you're doing object-oriented design, a lot of people are like, they're not sure, when should I make something public, private, protected, or just leave it by default? Rule of thumb, Never use protected or default until you're really comfortable with private and public. Private and public like get you a pretty far away. There are cases you want protected or something like that, but basically public just means anyone can access it. It's great for constants or things that should be available throughout the whole entire program. Most member variables should probably be private. And then functions, it depends. So like in this case, make move, we want to use over in this other class, right? So we need to make that public. We don't need to, but we should. Whereas these other things, play move and AI move, you might be like, oh, we're also using that here, but we're not anymore. Ideally, we want to hide like whether the AI, that's sort of the value of making this class. We want to hide, abstract away whether or not it's an AI player or not. Like if you're trying to just run the game, you should just say, okay, go to player one, get a move. We don't need to worry about this at all. Yeah.
Also, class, usually what I do in class is I mark the fields as private if they don't change.
Oh, yeah, yeah.
Private, I mean,
Oh, final. Yeah, you can.
Because if all your fields are final, then it's red state. So,
Yeah, basically what final means is you won't be able to like reassign to it later. So after this happens, like I can't go later and be like, haha, you know, whatever. I typically don't do it just because it's a lot of visual noise, but if you, some like places definitely recommend or style guides recommend you just mark everything final that you don't intend to change. Because if you do that, it also makes it very clear what is going to change. Like, oh, here's 6 variables, 5 of them are marked final. It's fairly obvious. Okay, variable 6 probably is going to change. So that's a great signal. I'm not going to do it just because it will clutter things up a lot. I think it probably should be the default, but it's not. So yeah, but that is a good point. Okay, so our make move, basically the reason I'm marking these as private is we want to hide the fact whether we're doing an AI move or a player move. So let's just completely hide that. And then over here in make move, we can actually like decide which one to use. And this is actually also not the final design we're going to use, but it's good enough for now just to get like a kind of one-to-one translation. So here we can port over our Boolean, whether we are in AI. Okay, so we've got that there. And now we can basically, we're still going to have that horrible logic, which I'll show you how you actually get rid of this. We haven't fully made it polymorphic, but what we are doing is improving our single responsibility, right? All the player stuff is now being ripped out of the board class. It doesn't need to worry about that, or the game manager class doesn't need to worry about that anymore. So we'll do if AI, AI move. Otherwise, what did I call the other one? Player move. Okay, so still not the best thing we can do, but we managed to basically extract, now the player logic is kind of extracted. Let's see what broke and fix it. So, okay, it says the constructor game manager player board refers to the missing type player. I think it still like doesn't realize that I made player. Yeah, if we restart it now, it's okay. Now it's just angry that we're passing Booleans, but our constructor takes players, right? So this doesn't work anymore. What we need to do is make those players. So let's do that. Player 1. And our player constructor, it's undefined because you need to pass in actually a couple things, right? Let's go back to that class. Oh, not that one. Okay, yeah, we need to pass in the character they're going to use. That's right. Okay, so we'll pass in our X. And then we can make the first player for now. Let's just have it how it was before. So the first player is not an AI, but the second player is. Okay, and so this is a little bit better. We've got basically the player logic is now extracting into its own thing, and we can make moves without the game needing to worry about whether the AI plays or not. It's its own module. Question. Yes. I could make it like this, but a lot of times there's not, from what I've seen, there's not a consistent way. When you start with like an acronym or something that's capitalized, like it would be kind of strange. Like, look at that. Does that look better? It's that to me, I mean, you could also do something like this and just say make AI a lowercase. Maybe that would be the preferred way. I don't know. In this case, yeah, I just chose to break convention. It's just convention. Nothing bad happens to you if you don't do it, except people will complain. Okay. The other thing that we need is actually the random stuff was all part of this AI move. So we need to move the random, like doesn't need to be here anymore. That needs to be part of the player. So we can add private random over to here. It's set all of that up over here. And we'll probably need to like import the random as well. So we'll just move that. So see, it's great. Like we're starting to move more and more things out of our main class here. And then what else? Is there anything else that's broken in here? What does it not like about this now? Oh, we need to actually pass in our players. So player 1, player 2. Okay, now it's happy about that. We still have some problems. So our move functions, right? They all rely pretty directly on these on the board, right? Like the player move, we need to print out the board so they can see what they're doing. And then the AI move just needs to know like what spaces on the board are valid. So it needs access to the board for that reason too. So there's a couple ways you could do this. You could pass it into the constructor here, like, and just say there's one board for every player. But I think a better way to do it might be to pass it into the method. And the reason for that is that way you could reuse those players across multiple games. Like maybe you want to play again. Well, how are you going to do that? If you just always pass in the board, then it can easily be switched to a new one if you wanted to change that later. So in general, use your constructor if it's something that's not going to change over the lifetime of the object. But if it's like something that is going to might change with like different method calls over time, that's a better candidate for a parameter. The other thing is if only some of your functions in your class actually need access to it, then like it often makes sense to make it a parameter. Like don't just pass in everything you'll ever need into the constructor. And then like only one function in the whole class use it. Like it's often better just to use a parameter. Okay, so we'll just pass in the board as a parameter here and a parameter here. That should fix some more problems. Okay, we have an error here because we don't have this method prompt. This is basically a utility function I wrote. It also was living in Game Manager, another responsibility that it should not be burdened with. And what it does, here, let's make it bigger so you can see it all. You basically enter a move, and it's what gives you that little like nice arrow and says, please enter a move, and then like reads in your answer and then returns what you did. So that should also, that's part of basically what your human player is doing. So let's tear that out and put that up here as well. And we can also make this private because we don't really need access to it outside the player, right? The outside world doesn't really need to know how that works. Not a problem. Okay, and then we'll need the scanner. That means the scanner needs to go up here as well. So let's go back to this view. So we'll move the scanner over to here. Move all of this over to here. Another thing you might consider is like passing in these random and scanners yourself. That way you could like reuse the same one. In fact, I think it might, if we actually make 2 players, I'm pretty sure this will break because you can't have multiple scanners to system.in. I think it breaks if you do that. So that's another thing you could do to improve the design. I'm not going to do it now because we are running pretty low on time, but that's something you should do. Okay, so we moved that scanner logic into there. So now we've gotten rid of all this, the thinking in the scanner. And now let's look at our game manager. We've made it a lot better. If we look, the whole file is only 38 lines now, and it's much easier to read what's going on, right? We basically just have the start game function is the main thing. In fact, something you want to look for in your own code that will come up after you, usually after you do refactorings like this, but just sometimes in general, especially if you're very class happy. If you have a class that has only 2 methods, one that is your constructor and one that is like an actual method, there's a case to be made. Why do you even need this class? It's basically just a function if you think about it, right? Because you could make these the parameters. What if we just did this and just pass these directly into start game? And so in this case, like main doesn't really have a lot in it. There's nothing wrong with having an empty main, but in this case, we can just literally cut and paste this into main and then just get rid of all this other stuff. And we might have some problems because things were named differently. Constructor player. Oh, wait. Oh, we don't. Well, here's the thing. So now we don't even need game manager anymore, right? Because we just have this one main method. We can just get rid of that. We don't need to start game because we have all the source right here. And look at that. Now we're down to 23 lines. Okay. And this is much more readable. If you're just trying to approach this project from the start and you went to game manager, which is probably not a very good name for it now, you could just call it like Tic-Tac-Toe Java or something. Because it's not even an object. Like we're not even making a game manager anymore, right? We're just using the static. Basically Java makes us have a class just so we can have a main function, but it's basically just a main function. which is completely fine. Our classes are more involved with the actual components of the game. And so, okay, this is pretty good. And if you read through this, like if you're new to the code base, reading through this, I think you could like pretty easily read through this and figure out what's going on. Okay, we make a board, we make some players. These arguments, the false and true is still kind of sus. Like, what does that mean? Unless you go read the class, you probably won't know. So we'll talk about that next. But you can see like, oh, player 1 is probably going to be X's, player 2 is going to be O's. Like it's easy to see from the code what's happening. And that's what you want to aim for. And then this loop, all of that makes a lot of sense, I think, as well. Okay, so it's pretty good. Let's make sure that it like still compiles and I didn't forget anything. Oh, okay. So player.java has some problems still. Let's see. Oh, okay. We need to actually pass in the board. So for this make move, we need to basically what we're going to do is say we need the board to do that, and then we'll pass that same board down into here. Okay, and then we'll probably need to update our game manager now, which why don't we just go ahead and rename that to Tic-Tac-Toe. And then we'll just pass our board in here. Okay. So now let's try it. File 9, oh, we renamed it, right. Okay, and look, we can still beat the AI, that's great. Okay, so now let's tackle this whole false and true thing. Like I said, Boolean parameters are kind of, you can call it an anti-pattern or like a code smell. This is what some people will call it. Basically something that like, if you see this, it's not guaranteed to be a problem, but it's maybe indicative of there's a better design out there. Just because Boolean parameters say very little about what something is. The usual way to refactor around a Boolean parameter is to basically make multiple classes or make multiple functions, one for each one. So instead of doing this, instead of saying we have a new player and we pass in this false, we could just say player 1 is going to be a new human player. And then it's then we can just know that it's going to be false in our implementation. And then we can set this to be AI player. And now this is much nicer. But okay, this is another example of me writing the API before we've actually written the API. So we need to go actually like write this up so it will work, but we want to go for something like this. So let's make human player.java. And this is where we're going to use inheritance. Okay, so all of the stuff that we've done so far, like we haven't really done any like inheritance or anything like that. Let me see if I can hide this. Oh, wrong thing. Okay. Oh, it's not going to like it. Okay, anyway, so we had this human player using the extends keyword and inheritance. This is really the first instance of why we're going to do that. So when you have multiple types, we want to have players that sort of all we can use in the same way, right? The main value in player here is we're able to do this. We're able to do this make move and have our players like make some kind of a move. And we don't have to worry about if they're AI or not. Okay, and so inheritance is a way to, if you have like multiple types, instead of doing, because remember I told you like this isn't really good design, like having this Boolean that tells us what type something is, and then like doing ifs, that's not an object-oriented design. So what you can do instead, so let's get rid of this, get rid of the isAI, is you make classes that extend and then override that function. So if we make this so it extends player, and so this will be the human player, so we'll need this player move. So move that into here. And we can get rid of all of this. And then let's also go ahead and while we're at it, let's make AI player. Like these are kind of related. So class AI player. And move the AI related code into there. Okay. And then this prompt is kind of useful for both. The other thing is this prompt can easily be a static function because, well, I guess not, because this, what you could do is make, so if you want to share the scanners across everything, like what you could do to get rid of around that problem I was saying before, where you have multiple, like you really should only have one scanner for system.in, you can make it static. And so that way it's like there's one scanner for everybody because not everyone needs their own scanner. They can all share. Same thing with like our random variable that like lets us get random values. Everyone can kind of share that. There's no need for there to be a whole bunch of those. So that's another use of like why you would want to do something static. Get rid of that. And so then we're able to make this prompt static. And we get rid of this because it just knows to use, it's a static method, so it only has access to static variables, which makes sense because it's not bound to any class instance, so it can't use anything like this dot anything. Like it can't get character C because which C would it get? Okay, so we have that. And then down here on make move, what we're actually going to do with this player.java class. So we don't actually want anyone to make a player, right? Because it needs to either be an AI player or a human player. So that's why you mark something as abstract. If it's like, this is kind of like a skeleton of like sort of what a player should look like, but there could be multiple implementations that take care of the problems in different ways. That's why you mark it as abstract. And so now Java will forbid us from making a new player. It has to be either a new AI player or a new human player. Okay, so this is pretty useful. And so we'll do this. And then here, the interesting thing about an abstract class is you can make abstract methods. So we can mark this make move as abstract and say, don't worry, like there's no make move is not something that all players will share. They'll all implement it in their own special way. But by marking it as abstract, the compiler will like force you to implement it in your other classes. So like if you try to like actually run this, like you'll get compile errors in AI player and human player. This needs to be extends. And it'll be like, hey, you haven't implemented these required abstract methods. So here we can actually implement these. And then instead of doing like different, this is AI move, it doesn't really make sense to have that anymore. We can just directly implement this and do our @ override. And same thing here. And then this prompt function, really this prompt function is only actually, if you think about it, really only necessary for the human player. So that's another sign like single responsibility principle. Maybe you're not doing things the best way you can. Because if you think about it, every AI player that we made also had this scanner access to the scanner, but it didn't use it. So it's like you're kind of like not only wasting resources, maybe that doesn't matter. Like this is a simple program, it's only going to use a few megabytes anyway. But just it's a code smell. It's an indication that like if your class has access to a bunch of things that it doesn't use, it's a sign maybe something's wrong. And so in this case, like the random is completely unused by the human player. The scanner is completely unused by the AI player. So we can actually just move each of the ones that are into the one that they're actually used by. So put that over to here, put that over into here. And we can just entirely tear that stuff out of here. So and notice also all of our files are starting to get much smaller. And they're also much more digestible. Now you can just read, if you want to know the AI is having problems, go read the AI player file. It's only 15 lines of code. Like it can't be that hard to find what the problem is. Okay, so over here, we still have this character here. It says it's warning that it's not used. So this is where you can start to not be able to use private. So if you want your subclasses to have access to a field, then what you need to do is mark it as protected. That's sort of the standard way to do it. You can also, since these are in the same package, we could just leave it as default. Like the default is a package private. So all of like basically everything in what you're shipping will work. But if you try to like other packages try to access it, they won't be able to. But this is why you would want to use protected. You could also do public, but then the danger is like maybe someone will come to your player and just modify it like at any time. And maybe you want to like not allow that. Or maybe you do, and then you make it public. Like it's up to you. But that's what you could do there. And then this prompt function, we can actually go and move into human player because that's who actually needs it. Okay, and there we go. We've gotten rid of most of the information in this class. So this is like a pretty standard what an abstract class might look like. You might have multiple methods, like maybe you want to provide other functionality. But yeah, this should be a better design. Let's see if this actually compiles or if there's anything that we need to change. Okay, let's see. Cannot override. Oh, okay. So our problem here, make move board in human player cannot override make move board in player. This is why that at override is important. It makes this warning happen because the problem is attempting to assign weaker access privileges. Was public, we marked it as private. So this is why the at override is important, because then it will like, it knows, oh, you're trying to override it, but oh, you did it wrong. Like, let me help you out. And you'll get much better errors than if you don't put it and like something else will break that's like related, but not actually the problem. And so this needs to be marked as public because it's marked as public in the super class or that parent class. Okay, and same thing here. Okay, and now actual informal argument lists different length. Okay, so the thing that's going on here is in order to, since we have this player constructor here, we have to call what's called the super constructor. Okay, so if you were like, what is the super keyword? Like, why do you need it? Basically, when you call super, it's like kind of like copy pasting player, since player is the super class, right? It's called the super class because it's the parent or super class. And so when you call this super thing, it's called the super constructor. And that is this constructor. It could be, if this one has multiple, it could be any of them, but you, based on the parameters, it will know which one. So our super constructor requires us to pass in that character, and it requires us to pass in if it's a, actually, we don't need this anymore, we get rid of that. So it just requires that character. And so what we can do is just set up our constructor here to basically pass in a C, and then we don't set the C ourselves. So we could do like something like this. But instead what you do is just pass it to the super constructor and let them worry about how to store it because they've presumably already taken care of this. I thought that, but it didn't compile. Although, I don't know. We'll just do it. Being explicit is often better anyway. And if you have other arguments, so sometimes maybe your AI player is going to have like, you know, an AI strategy. So like maybe you let it be random or you let it do something else, whatever. And then you can pass. And then if you have extra parameters, then you'll need to take care of those yourself. But you can pass in all the things your super constructor can do into that. Oh, it should. So we shouldn't do this. It's warning about this because it's static. So it's not belonging to us. It's just any instance can use it. And then let's go fix it in human player, fix our problems. So we'll take in a character C and call it super constructor. All right. Hopefully this time it works. All right, there we go. And now we have yet another program. Oh, something broke though. We entered 3. Oh no, he picked 3. Shoot. So let's pick 4. Oh, okay. The computer beat us because my strategy wasn't very good that time. It got lucky. But yeah, it still works. Okay. So that's pretty good. So let's like just kind of take a look at the files we have now. We have a whole bunch of like class files and stuff. But we have board.java taking care of our board. We have our AI player and player classes that are taking care of our players. Then we have Tic-Tac-Toe, which is like our main driver. Okay, so we've managed to improve a lot of those things. Let me see if there's any. I think now I'll be able to have some time to talk about some of the other the things that are left to change. Like this is a fairly good object-oriented design. So the main things you want to sort of note about it. If we go to tic-tac-toe.java, instead of having if statements based on the type of something, we handled the types by creating different subtypes. So we say, okay, we have a human player, but we can use it through the regular player interface, right? We don't need to know it's a human player. All we need to know is that it provides the same things a regular player provides. And that way we can call it the same way. Look, this one right here, this is a human player. This is an AI player, but you can use them in exactly the same way. You don't have to know which one you have. You don't have to do any ifs or checking like that. That's not a problem. Yeah.
Oh yeah, I was gonna say for player, the way we're using it right now, player could technically pass as an interface instead of an abstract class.
You could. In fact, why don't we let's look at that so we can see. So that's the other like major Java topic you may have seen in your class and may have been confused about is what an interface is. Actually, I think this is a design flaw in like the way Java is written, that you have both interfaces and abstract classes because they're basically the same idea. So let's open up our player. The proposal here is to make this into an interface. And so if you make an interface, click interface player, An interface is exactly the same as an abstract class with the following differences. I don't think you have to mark things as abstract because everything in the interface is abstract. So you can't implement anything, and you can't have fields that aren't just constants. So the only problem is we won't be able to carry over this C. But what we could do is move that C into each individual player. So like have each one individually like take care of that in the constructor, which might be the better way to go anyway. And we can just say that now, look at this. We have this nice little file here. A player is just something that can make a move. And so I actually, in general, like my recommendation would be to try to favor the use of interfaces. The other thing that's good about interfaces is that you can implement multiple interfaces. So what we're going to change in our human player and AI player is now use the implements keyword instead of extends. And what's cool about implements is you can implement, multiple things. You can only extend one thing. So if you want to be able to act as both a player and something else, like in this case, it's probably not a huge deal, but that is a real limitation you'll run into. Sometimes you're like, oh, especially in some kinds of games, like you might have, you want to say like an object is movable, like it can move itself around. It can also be destroyed, so it's destroyable. And so like it has a destroy method that has this. How do you implement both of those? You might want to have one interface for this, one interface for another. That's a really good design, something called the interface segregation principle. You want basically the more interfaces you can have that just have one method on them, because you can put multiple methods on the interface. You can have like 10 methods on it. But that means that your interface requires so much from people who want to implement it. If they all just have one, then you can kind of pick and choose what things you need. And it's very composable. So you can say a tree is not movable, but it is destroyable. A person is destroyable and movable. A wagon is movable and destroyable. And you can just pick and choose what you need for different things. So that's the benefit of doing like an interface design. The only problem is then this char C will have to like store ourselves, which is not a huge deal. And we'll have to go do the same in AI player. Okay, and let's run that. Okay, still works. There we go, we won. And with that, I'll take any questions because we're very short on time. Let's see, Zoom chat, any questions? Okay, then I hope you learned something. Thanks for coming out to my workshop and have a good night.